Hi folks, Dr. John Raymond Baker, DC, and today I wanted to talk about a little bit of a serious topic that's kind of understating it. It was brought to mind, or at least the impetus for the video, was a news item today. Today's Tuesday in the latter part of June 2014, and it was talking about that they found the polio virus in the sewage near Sao Paulo, Brazil, an area not far from where some of the World Cup soccer guys were training. They were quick to point out in the article that they haven't found any human cases and that in fact the virus strain of polio that they found in the sewage sample was similar to a wild type found in Africa. And the thrust of the article was to allay fears and to indicate that in 1989, I believe, Brazil had done this sweeping vaccination, and most of the Americas, South America, North America, had been polio-free since 1991. That said, they were saying that there still is a very serious problem in Africa with polio, and that there's so much travel nowadays, and especially with folks internationally coming to Brazil for the World Cup soccer finals, that it's a problem, because even though you get it contained or eliminated in one area, you can have problems in other areas. Now, isolated, that might not be a big deal, except that there is no cure for polio. There is a vaccination that Dr. Jonas Salk was responsible for bringing to fruition. However, there is no cure once you've gotten it, and it can lead to permanent paralysis within hours. So polio virus is not something to take without a great deal of concern. Now, like I say, isolated, that's just one event. But what I see is a confluence of a lot of events and a lot of things that should be concerning to all of us. Now, a few days ago, I found an article that said for the first time they had found antibiotic-resistant bacteria in foodstuffs. And so I kind of hunted down what the foodstuff was, and it was bacteria found in squid. And you'll forgive me, please, if I glance down and read occasionally, because I hate to get anything wrong. Researchers in Canada have discovered one of the deadliest kinds of antibiotic-resistant bacteria for the first time in a food product, raw squid, widening the potential exposure for consumers. Most antibiotic-resistant bacteria have until now been in healthcare settings and spread by infected patients, so as occurring in the superbug outbreak at the National Institute of Health in 2011 that killed 7 people. And you know, we say kill 7 people, but if one of those people was related to you or a close friend, it really brings it home. But the truth is, I would want to differ somewhat with that, in that MRSA, MRSA, methicillin-resistant Staph aureus, used to be confined to the hospital setting, but the truth is that it's gotten out into the community at large, and you find it being spread among people, athletes in high school, all kinds of settings. So really, to say that it's just a nosocomial or hospitally acquired infection is kind of to minimalize something that's really worse than you're painting it. So we're seeing the first antibiotic-resistant bacteria in foodstuff. We're seeing virus, the polio virus found in sewage in Brazil, ostensibly brought in from another country, where it is still a real big problem. But on top of that, we're seeing that there are other pathogens, sexually transmitted diseases, STDs, for example, syphilis, gonorrhea, etc., who are becoming resistant to bacteria. MRSA, also known as MRSA, methicillin-resistant Staph aureus, that was able to be fought by vancomycin, a very strong, expensive, dangerous antibiotic. Now there are vancomycin resistant strains out there. And where we're headed is a state in which there's going to be many bacteria that are resistant to antibiotics, and I assert many strains of viruses that mutate to the point where they're totally different viruses that we don't know anything about. Now, another thing that you'll be noticing, and this is often presented tongue-in-cheek, is this whole deal about the zombie apocalypse. In fact, the Department of Defense has gone to great lengths, coming up with plans to deal with a quote-unquote zombie apocalypse. And the CDC has talked about the zombie apocalypse, and that might be funny if it was on Halloween. However, it does give you pause to consider why they keep hammering away at the zombie apocalypse if there is no such thing as zombies and they could not be created. Now, I don't believe that zombies will ever be around in the sense of dead people who become reanimated. Literally are dead for a day and come back. Truth is, though, if you watch most zombie films, the zombies that bite other people, the person that gets bitten really doesn't usually die so much as they just kind of go into a temporary quiet period and then they come back with the zombie deal. Recently there was a television show that talked about, could you really have a zombie like outbreak that would be dangerous for the world? And in fact, what they decided was yes. And the most probable candidate for the pathogen that could create such a scenario would be the rabies virus. Rabies is incurable. It causes people to become very aggressive, to basically become another person. So what if the rabies virus mutated in such a way that it kept people alive longer and fundamentally caused them to become, for all intents and purposes, zombies? That's something to keep in the back of the head. There's other things that are going on too. But you've got this problem with antibiotic resistant bacteria, which in no small part, and the CDC acknowledges this, has been caused or at least promoted by farmers who have been feeding antibiotics to their cattle for a long time. Primary reason is not so much infection control as it is to pump up the volume, increase the size of their herd cattle, make them put on weight faster, etc. Somewhat in the same way that someone that takes steroids, anabolic steroids, can put on muscle much faster than an average person. So we've got antibiotics being found in food that are resistant to, bacteria found in food that are resistant to antibiotics. You've got poliovirus found in Sao Paulo, Brazil. You're finding MRSA that's resistant to every antibiotic known to man. And recently it was in the news that they had reconstituted the supposedly the Black Plague pathogen. And why would they do that? We don't know really. They always say research. And another thing they did was dig up the flu virus that kills so many, the so-called Spanish flu that during the First World War killed more human beings than the First World War did. And in fact, the flu was a devastating killer, and it went away without them really knowing why it went away. It wasn't that they came up with a magic bullet and solved it or anything like that. Now, in the mix, because you have to understand that viruses bacteria, and if we want to interject the proteins called prions that they believe cause things like mad cow disease and Creutzfeldt-Jakob disease, which is kind of a human version of mad cow, which could also be a candidate for something that could cause a zombie-like plague, if you will. On top of all that, we've got an interesting fungus called Cordyceps unilateralis. Now, what is Cordyceps unilateralis? I kind of like saying the word. It's, and I'll read from my document here, it's an entomorphopathogenic fungus. It should say entomorphic, they misspelled it. Predominantly found in tropical forest ecosystems. First discovered by naturalist Alfred Russel Wallace, who, if you know much about the theory of evolution, he was kind of neck and neck with Charles Darwin in 1849. And why is this fungus interesting? Well, some of you may have heard of a fungus that can literally take over ants and turn them into slaves doing its own bidding. And I know I'm anthropomorphizing, giving human traits to this fungus, but the more you learn about the fungus, the more appropriate it seems to give it human traits. What happens is, I want to kind of read what they say about it. In order to increase its own fitness, O. unilateralis utilizes the evolutionary trait of an extended phenotype to manipulate the behavioral patterns of an infected ant, specifically Camponotus leonardi of the tribe of Campotini. I don't know why they say the tribe, it's an ant, but maybe that's cool to say. The infected ants leave their canopy nest and foraging trails. In other words, they abandon their normal lifestyle, heading for the forest floor in search of an area with a temperature and humidity that is suitable for fungal growth. In other words, they forget their normal overstating it. The science fiction nature of this whole relationship between the fungus and ants can't be overstated. It's not uncommon to see it well, they're just talking about it's not uncommon. Basically, what this thing does is, I might have to read a little bit. This fungus targets these ants. It may also parasitize other closely related ants with lesser degrees of host manipulation and reproductive success. The fungus spores attached to the ant eventually breaking through the exoskeletal using mechanical pressure and enzymes. And that's pretty strong. I mean, if you know much about the exoskeletal of an ant, that's a pretty good feat. Yeast stages of the fungus spread in the ant's body and presumably produce compounds that affect the ant's hemocoel and utilizes the evolutionary trait of an extended phenotype to manipulate the behavioral patterns exhibited by the ant. And here is the more strange part to me. The infected ants begin to have irregularly spaced full-body convolutions, which sends them to the forest floor. The insect climbs up the stem of a plant and uses its mandible to secure itself to a leaf vein with abnormal force, leaving dumbbell-shaped marks on it. And they say a search through fossil databases reveals similar marks on fossil leaves from 48 million years ago. So it's a pretty well adapted little creature. Once the mandibles of the ant are secured to the leaf vein, atrophy quickly sets in, destroying the sarcomere connections in the muscle fibers and reduces the mitochondria, yada yada. The ant's no longer able to control the muscles of the mandible and will remain fixed. This lockjaw trait is known as the death grip and is essential to the fungus's fitness. Now you'll notice that the ant really doesn't matter anymore, only as a vehicle and a robot for the fungus. Fungus then kills the ant, continues to grow as its hyphae invade more soft tissues and structurally fortify the ant's exoskeleton. When the fungus is ready to reproduce, its fruiting bodies grow from the ant's head and rupture, releasing the spore. This process takes 4 to 10 days. So like something out of Aliens, it literally explodes the head of the ant. And on earlier versions of this, I've seen that it talks about the ants being controlled to the point that they'll actually find a tall bush, tree, whatever, crawl to the top of it before this ant explosion, before all this other bad stuff happens, so that when they're in the top, they're actually in an optimal position because of the height to disperse these spores as much as possible. So this, and they talk again about the extended phenotype. But the idea here is that you have a fungus, a very simple, relatively simple organism, that is able to take another organism completely over, basically zombify it, and make it do its bidding. Now, I might have lost you, and you wonder where I'm going with all this. But what I see is a real problem developing in that the allopathic medical community has for a century and a half or more, seen a pill for every ill, that medication will be the be-all and end-all of your problems. If you've got diabetes, take medication. If you've got an infection, take medication. But what we're seeing is, especially in the area of transmissible infections, that these viruses and these bacteria especially are getting pretty smart. Not only are they getting smart, but they're able to transfer some of their resistance from one to the other. So one strain of bacteria may be able to transfer its resistance to antibiotic B, and the other strain reciprocates with its resistance to A, and now you've got two strains that are resistant to A and B. And I think that it's a situation that the medical community is getting very concerned about. Your average doctor is not on your local TV station talking about it very much, but you can imagine what a nightmare it would be if staph infection, there was nothing to help you with it, which is getting to be the case with MRSA, for example. Some of you may have heard of a type of infection called galloping gangrene, caused by a form of strep, which is basically a fairly common element of the environment, that for whatever reason a person just becomes very susceptible, and their immune system basically says, I give up on this one, I don't know what to do, and it can literally destroy a whole extremity or a big part of your chest or your side in a matter of hours. And that's just a strep infection. Now imagine if you had something like the Ebola that somehow hybridizes with some other virus like polio or whatever. I mean, the possibilities are endless, because viruses and bacteria are able to mutate very well. And as we see for 48 million years, funguses are no slouch either. So I guess what my video is doing is raising a clarion call about this issue of the overuse of antibiotics, for one. Broad spectrum antibiotics have been overused in humans for some time. And for example, people that might have a viral infection, respiratory infection, go to a doctor, and the antibiotics don't work on viruses, so they might not have anything to give you, but the person insists on an antibiotic because they don't believe they had a valid transaction in a doctor's office unless they walk away with a script. And the AMA warned doctors, don't be doing that. Don't give them antibiotics if they don't need it. If they don't have a good reason for it. But poor doctors, faced with an angry patient, often succumb and write out a broad spectrum, clindamycin or Bactrim or whatever. And the ultimate answer to this race, this whack-a-mole race between humans and pathogens like bacteria and viruses, is not just to keep coming up with one medicine after the other, hoping that it'll take a while for them to catch on to how to become resistant to it. And in the case of prions, prions, proteins that are coiled in a strange way, I don't know what's going to happen with that, because mad cow disease, the other day there was 4,000 pounds of meat that had been recalled because they suspected or that it had been infected with mad cow disease. Those sorts of encephalopathies, mad cow, Creutzfeldt-Jakob, once you get it, you can die. But with some of these diseases like kuru, these kind of prion-related things, it can take years, even decades, before you suddenly go into foaming at the mouth and you go mad. So I can foresee something happening where Creutzfeldt-Jakob could hybridize or mutate to the point where the cycle from infection to symptoms gets condensed greatly, where you go from being infected to complete madness in a matter of a few days or week. But somehow you're able to function till that minute where you go crazy and start killing people or whatever. So on that happy note, today's Tuesday, not Friday. I usually do the vids on Friday. But I hope you're having a good day. I hope you're enjoying the summer. But put that in the back of your mind, especially if you're a farmer and you're in the habit of, or were in the habit of giving antibiotics to your cattle. Not cool. Have a great day.